Natural. Hey, can I get a snap? Hey, I'll just take
yeah, wait till Caruso gets back.
Alright. What do you mean? Where are you?
I got to dress up before.
Yeah, he was dressed up before. Where's it all go? Watch this. You go grab my backpack.
He took like ghetto sunglasses.
That's not working.
It's broke. It's nerds. By a bunch of nerds.
From the trainer. Come on, you nerd. Whoa. Britney Spears joined the Omega Room, you Scotch kid. Yeah. Like a napkin tape at the very least. How do I get this back in here?
I thought
Tape to get over there. Britney Spears joined the Omega Room.
we look like strippers.
Yeah, you look at the girl from It's not like any different. Caruso.
Get out of our country's way.
They did the picture early. I don't know how you do it.
Is that part?
You have another outlet over here?
I'm walking around. Where's Cindy? What is Cindy? Was McCready so nerd?
Yeah, no, actually,
I once you saw your grades, Sarah, back there, Carolyn. Carolyn, you made a mockery of it. Made your test before that.
Is it working in the gym now?
Yes, Nate.
Normally I get mad, but I want confidence to be high going into the walk. You know you got toilet paper. You got your shoe, right? Was that on purpose? No. Oh, oh my God. Pass it back to Mark. Pass it back to Mark.
Nate, is this a black and white camera?
Yeah, it's a black and white viewfinder.
Oh.
White really bad. Allison. Greg over there. Sarah. We're all getting one. Sarah, please. Mike Fishman. You just kidding. Dorian. Wait, how much do you Jimmy? You pass one to Jimmy.
Hey, Matt, why don't you put up the
Mike Pagosa.
Oh!
Hey, Greg.
Oh,
No,
yeah.
up front. No, up front.
I know, it's fun. Nerdy. That is nice. Alright, that's that. I have homework salutes from last night's stuff. Get that out. Show me you have it, you can get salutes. You didn't do it? Oh, you talked to me, you're right, yeah. You got it done? Alright. Karen, you got it done?
Okay, we're putting this on a chair or something.
Hey, Sid,
Why don't you put it on the trash can table, Mark?
When you guys were PhD?
Yeah, I did do it.
Photograph ones? Okay, good.
I had to finish on one.
See how it looks. How does it look in the
You got homework from last time? Joe, you got it done, you showed me. Mike Fishman, you got it done? Cool, you got it done?
Yeah, of course.
I'm still pretty sure it's
Mark, you got it done?
This?
Last night's? Yeah, that's
it's
nice.
just negative square.
Mark, go to PJ's, the whole class.
Yeah.
Fifth of it. When I run? Check my salutes. You do it? Yes, I use. You do it?
I sometimes not knowing the blonde today.
Wow.
You want to go on it? Hey, you didn't have to dress up like a nerd, Dad. You want to take him? Yeah. We'll give him away. You do it, Mike? That's all my food. Yeah. Sarah, you did Jimmy. I saw you in there doing it, even though you checked your lazy.
Yo, let's stop talking to me.
Hey, yo!
Hey.
Nerd.
Is it better on the trash can?
Yeah,
All right,
I love it.
it's some of them. I have 3 of them. I have them on my desk. You can check them out afterwards.
That wasn't pretty.
All right,
It's angled down.
Where's Layla?
Little G, I got 0.554. You got 0.554.
It's in my glasses, too. My Bloody Holly glasses. All right, I have tonight, actually, take a look at last night's stuff, see if there are any quick questions. It's nice having all these pens. Maybe I should be in there.
Really could be this.
Seriously. You are here. Take a look through last night's homework. That's fun. No, it's the shirt. You gotta have like toilet paper on the heel or something. was gonna go bow tie, but I kind of go bow ties when I dress up sometimes. I don't want to lend credence to it being nerd-like.
It's just like dudes like weightlifting, so it's kind of not nerdy.
Kevin brought me an apple today.
What's 6 times 3?
Nerd of the day.
You in?
She's a nerd of
Well,
mine. She's a teacher's pet.
Yeah. We all have a lot of candidates for nerd of the day here. Kevin brought an apple though. Who's that?
You did it. I was gonna do it, but
What?
I didn't want to go that far. The hair.
Oh, the hair, yeah.
Yeah, I was gonna do
The
it.
butt cut? Oh, that's fantastic. Everybody in my 6th grade class had hair like that, including yours truly. There was also mullet style.
I so want to see it. I so want to see his yearbook. We saw Mr. Lipinski's yearbook page, yearbook photo. I want to see yours. Can someone do me
My
a
high school
favor?
yearbook's alright.
Someone divide 72 by 49.
Wait,
The
isn't
mullet was like my 6th grade. I can find something. Cut hair, long in the back. It was nice.
Oh my god.
It was like Mike KT's with a little more volume and a little more length in the back.
Do it on Grease Day. That's what we should do.
wait, why?
Yeah,
Why
it's not really
is,
Oh,
spirit,
that
but
was in
spirit
high.
4
why
days.
is 2A?
We had a Friday,
I
yeah.
have 7. Let's do it on Friday.
Yeah.
Let's do it on Friday.
Friday we're not meeting, Judy.
Right, we can still dress up.
Sure.
No, no.
What? I'm not going to be here that long. I'm only class at 2:05.
If you can round to that. Or,
No, it's around.
Oh, he does in the toilet paper slot.
You know why you got 7?
If you do it right,
I think I'm just gonna go home with it.
Because they told you at 3, there's a vertical tangent. You say,
You start, like, when are you gonna
x
do
equals
this?
5.
I'm comparing.
What about
Vertical
2A?
tangent, there's no derivative. Slope is
So it
undefined.
has nothing.
So
to do
at
with
3 is
that.
nothing.
I should have changed mine to
That
that.
makes sense?
Because I'm gonna have to
Alright,
read the
try to
book.
focus a second, go through these so we get to the business, and then we'll talk about what's happening from here on out.
I got, whoa.
And I wouldn't mind doing, I think, is number 5, number 5 is the one I wouldn't mind doing,
Yeah,
5B
number
and C, just to explain. The first part of 5C, that was to make sure nobody got 100 on this thing. I'll explain.
The what?
When we go over 5B and C, I'll explain it. They threw it so to make sure nobody gets 100. Hopefully you got 6 all right.
Yeah.
I just think at 3D,
We'll talk about 3D because that's something that came up on one of our questions yesterday too. Are those prescription glasses, Nick?
yeah,
You go contacts?
yeah, I can't stand it. The 6th grade, my mom bought tortoiseshell glasses. Couldn't get out of them.
A lot of great people used to have tortoiseshell glasses.
Who did?
You did.
You have contacts?
Well, now I had corrective surgery.
That worked?
Worked for me.
Yeah, that's for sure.
That's right. So 5B or 5 B and C, and then 6D or 3D we're talking about. Anything else? Let me know. Hopefully you guys rocked 1. Hopefully you rocked
I had
6.
issue on number 2.
To what?
I had issue with 5, so it's about 108.
Okay. We'll talk about that too.
Why is 3C from 2 to 3 and then from 2 to 5?
They tell you there's a vertical tangent line.
Yes, it's fine.
And so the derivative, so there's the function, the derivative is not going to exist. It's going to be negative on either side of it. At 3, it's nothing. And please don't ask me that, so that would look like graph.
Are they really into, like, the base is a square or a circle?
Sure, that's pretty easy though.
What'd you ask?
Dorian's talking about 1C. You've got this region, and they're saying each cross section is a square that's perpendicular. Well, you know this is going to be the top minus the bottom, which is either negative x squared minus 1 plus cosine x. What's the height of that square have to be? Same exact thing. That's, did you get that one? What was the problem? Well, yeah, it's so solid that every time they take a cross section perpendicular to that base, it comes out as a square. You know the base of the square no matter where you go. You got a series, you got a bigger square out here, a little square in here, medium size. You got all this, yeah, it is tough to picture, but a bunch of squares sticking out there.
And did we actually have to use a stat plot, or was that just my imagination?
Stat plot.
Yeah, they said Is that the time?
Number one?
No.
All right, hang on a second. Number one, the rest should be straightforward. It's okay if the volume is smaller than the area of the region?
What?
Is that okay that the volume in C is smaller than the area of the region in A?
Yeah, because it doesn't cover them.
Well, it does. This base is 5.591, but you're only hitting it. Welcome. Here's Saloons for last
Those
night.
shoes are great.
I'm going to take another picture.
And here's your test from last week.
Nerd alert.
I don't know. It's not very nerdy.
All right. So, boy, think about this.
Go easy.
Just think of this slice right here, from here to here. Just estimate how long is that? Yeah, just estimate though based on the picture.
0.8.
0.8. Good. So what's the height going to be?
8.8.
Yeah. What's 0.8 squared?
160.
So it's smaller than actually the length because we're dealing with different units. We went from distance to square area. We're going from area to volumes, units cubed. So don't be thrown off by C being smaller than A. All right, moving on for number 2. Now, I made this mistake on number 2 at first until I checked it. As you see by my solution, when they were asking me the velocity of runner A at time 2, I just looked at the graph. What do the words say on 2A?
Velocity, yeah.
It says find the velocity.
Not approximate.
If it said approximate, you can look at the graph, like, see how I marked on the graph? I said, oh, that looks like 6. Now, they want to find the exact velocity. How did I get 20/3? Made the equation that line, y equals 10/3 x, plugged in 2, and you got 20/3.
That's what I did.
Now,
Y equals 10/3 x.
right.
So
If you would just write it down, I think they'd understand.
when in doubt, just show us.
Sure. Yep. Now, B, the acceleration. Sydney, you were asking about this. Sydney, what is acceleration in terms of velocity? It's the derivative of velocity. What's another way to say derivative? Slope of the tangent line. Where's the tangent line at time 2? The tangent line is that line.
Right.
What's the slope of that? It's like 10/3.
It's not like that.
There you go. That's the acceleration. Now, units for acceleration. If velocity is meter per second, acceleration is what? Meters per second squared. I don't really understand what that means. If you do, don't tell me. All right. C.
I really want to tell you.
C, the distance. I lost the. That's good. All right. C, the distance traveled. If this is velocity, we want the distance. What do we want?
The area.
Yeah, we want the integral of it. This is the rate of change to find out how much stuff we had, how much distance we had, integrate it, or find all this area. And that's what I came up with for distance of runner B. Took the integral of their velocity formula. 2 should have been, at least now, hopefully should be pretty straightforward. All right, on 3D, they ask, where's the absolute maxes occur? Tell me, where can absolute maxes occur? When derivative equals 0 or endpoints. Okay. Now, we already found, or where actually can occur at relative maxes. Were there any relative maxes? That was part B. What do you get for B? Relative max at x equals -5. Endpoints, and these are possibilities. Endpoints are -7 or 7. These are all possibilities. Now, I'm going to make a statement, and somebody besides Dorian is going to answer me. You're the one I did this with before, right? You. Yes, you. You can't answer this. But Dorian, didn't we do this last night? Yes, sir. Relax. What did you say? Shut up.
They left your shoes under the bed.
Oh my God!
Hey! You got problems.
They're all bad.
Issues.
The day before the AP.
I'd love to, but he needs too much in this class. All right. Look at the picture. Don't look at the slews. Fold it over. Tell me why this is a true statement. Raise your hand if you think you know. Look at the picture. Don't look at my answer. Just look at the picture. Why is this a true statement? Yeah, Layla.
Because up as you go from negative x equals -7 to x equals -5, the derivative is positive, which means that the slope was positive, which means that it was increasing.
Right. The function is increasing. The derivative is positive. The function is increasing from -7 to 5. So we're at -7. It's increasing up to 5. So this has to be true. So we can get rid of -7. That's no longer a possibility. Now, we'll make one more statement. I claim f of 7 is bigger than f of -5. Somebody else look at it and try to answer this. And Greg, I'll call on you so I can give people a second to think about it. Greg, why is 7 bigger than 5?
Because it's mostly positive past that, but very negative, but usually.
Here's what we've established. We know we start out at -7. We've established it increases to 5. After 5, what happens? It decreases for how long? Not too long. It decreases. Then what happens? There's a hell of a lot of increasing going on. There's a lot more increasing from -1 to 7 than there is from -5 to -1. So it's looking like 7's up there. 7 is the absolute max.
How do you think like that?
What did they say? They said justify your answer? I would write this is because it's increasing from x equals -7 to -5. For the bottom one, I'd say there's more increasing than decreasing. That will be good enough to get it. All right? That's a good problem. They like putting that stuff on there. Moving on. 5, the only one I really wanted to do starting out, but those other questions were good. 5, they told you here's the function. Oh, I don't have it written down. Somebody give me the function.
xy squared minus x cubed y equals 6.
Okay, great. And we found out in part A, I'm not going to do that. It's implicit differentiation. That should be pretty straightforward. Okay. There's the slope. Now, part B said what? Equation of tangent line when what? What did part B ask for? Okay. First of all, for part B, x coordinate of 1. How are we going to find y?
Plug one thing.
Plug it in. Plug it into our function. You get y squared minus y minus 6 equals 0. Is it a coincidence that it works out so nicely?
No.
Why is it a coincidence?
Because there's no calculator.
Because it's no calculator. Factor it down, y minus 3, y plus 2.
There was the whole thing, no calculator?
Yeah.
These last two, 5 and 6 were. Y equals 3 or -2. So now, our 2 points are 1, 3, and 1, -2. Now they asked, then write the equation of the tangent line. Well, take the top one. Y minus 3 equals the slope times x minus 1. How am I going to find the slope? Plug in where? Plug in dy dx, and I've got this written down somewhere. You end up getting 0. Now we've got y minus a minus 2, or y plus 2, equals m times x minus 1. Throw in this xy, get the slope. It came out to be 2, and you're in business. Now, this next part is kind of fishy. Not fishy. I don't like the question. I think you guys could have done it if not for. Well, hang on. Let me do it, then I'll tell you what I don't like. All right, part C. They want to know when the tangent line is vertical. What's the slope of any vertical line? Undefined. A vertical line, there's rise, there's no run. It's division by 0, it's undefined. So we want dy dx to not exist. When could this function not exist? That's all you're doing.
Oh, but I can find like.
Yeah, I'm not stopping that. Factor out the x. So now, possibilities for this not to exist are either x equals 0 or 2y equaling x squared. Easier to think of that as y equals x squared over 2. If you throw in x squared over 2 for y, you get 0. Throw in 0 for x, you get 0. Those are the two possibilities. Now, if you go through here and you think, okay, x equals 0 is fine. What happens when you throw in 0 for x here? 0 equals 6.
That's not.
So now, this is what I'm saying. This is the 100% buster right here. I don't know if they always do that, but I don't like this. Because you go through and you say, okay, x equals, because what did they ask for specifically in this one?
That's the x coordinate.
X coordinates. So you think, oh, x equals 0, we're in business. But you're really not. Because when I first did it, I circled it. I'm like, great, they gave us one easy one, now you go through and solve for x over here. We'll do that second. Because 0 doesn't work. Yeah, it creates division by 0, but 0 is not in the domain of this function. So really, this gives you nothing. I think that was the 100% buster right there. I don't care about that. That's for nerds. The part over here. How am I going to find the x now that I know? Plug it back into where? The original equation. Y equals x squared over 2. I get x times x to the 4th over 4 minus x cubed times x squared over 2 equals 6. This works out real nicely. Make this into 2/4 instead of 1/2. You get negative x to the 5th over 4 equals 6. Negative x to the 5th equals 24. Negate it. 5th root it. You're in business. That is...
no calculator.
You don't have to simplify.
Oh, that's right, okay.
Yep, no, leave it like that, absolutely. I first did this not realizing I had like these huge decimals and it worked out, but there's no calculator. So, you got to go through and solve it. Tough problem, no question here. A and B, I think you should have gotten pretty straightforward. Tangent lines are easy. C, I would have been happy if you got down to here and even been stuck here. Right? Figuring out that this didn't exist, that is for nerds.
The last one,
I don't want you getting that one right.
All right.
the last one or two are the hardest, right?
General. So except 6 in this case, I thought was pretty easy. So 6 was a differential equation you solved for C. They asked me domain and range. Whenever you do domain and range, picture the graph. We have an LN graph. An LN graph looks like this. What's the domain of that graph?
0 to infinity.
It's positive, right? Positive x value. So in this case, we have the ln of 2x cubed plus e. We need 2x cubed plus e to be positive, and I have it written out from there. ln graph, what can y be? Anything. All right. That was last night's. Yeah, they don't change the exams too much between, or they didn't change the topics on the exam between last year and this year. So this 2000 one's a pretty good indication of what's going to be on there. They're obviously going to change the problems. I know everybody has this. But there you go. How are we doing? All right. Here's what I want you to do. I'm giving out to you tonight's homework.
We have like solutions.
You got it all.
Nice.
I've been photocopying like a crazy
And
man.
the solution, right?
As only crazy man's photocopying. Are the solutions correct?
Because that one,
I hope so.
The one when you went on that field trip, whatever, and gave us for that with the practice test.
Right.
Yeah. Then you'll fill you.
Yeah, he's purposely giving us wrong answers.
Give me a call at home.
Alright. We get your number?
We don't know
Give us
your
your number.
dad. What's your
Yeah.
number?
What is it?
1-800.
Call Rick.
Check back in the morning. Send that down. All right, there's the homework.
Your dad. Bring a breakfast tomorrow.
Yeah, are we going out
We're
to
talking
Denny's?
about all this. Relax, everybody.
Who wants to go out to Denny's?
Hang on.
I'm here.
It's early. This was from the book I got. Yeah, so I know these two are right. I know why.
If anyone wants to do some multiple choice, I have a blank test book here that I can put up.
So anyway,
I've been doing multiple choice all day long.
no, it said 1988 is what it should have said. Ignore that. It just said 1988 before. Everybody's got, pass these down, these are the solutions. No, it's from a book that gives solutions and stuff like that.
Is this your handwriting?
No, it's not my hand. My handwriting's the page after that.
Yeah, good.
There you go.
It's late to do this.
Mr. Sanders gave me a copy of the test. If anybody wants it, $25.
No, it's actually trying to just be a pizza thing. That's why I said scrap it. When they first said it was possible, but then they said they're just getting pizza at the playground. We've done that. It's not the playground.
And we're going to show up with our garlic sauce. Are we going to have a party?
Hang on.
Seriously though, guys.
You got 13 more minutes to sit here and listen. I will take care of you.
Why don't we show up with like ski masks and our shirts?
Everyone south.
Pass this
Seriously.
down.
$25 will get you a copy of the test.
Wait, what did he say?
Talking to Miss O'Sander. Oh man, I hope she's not proctoring.
Yo,
Mark, you realize we have this on tape.
Whatever.
We had the whole exchange with Levine and this.
All right. Quit speaking. Read through this. The T-1 sheet.
No, okay.
Come on.
Is the fourth point down supposed to be F prime of X, whatever? 6.2?
Yeah, it says F, that should be F prime of X.
You need to know about linearization.
Shush.
What would happen on the test
Shush.
that Jeremy?
Shush. Breathe it. Shh.
We don't want it.
Are you guys done reading?
Yeah.
All right. Tonight, at some point before 8 o'clock, sit down, set a timer for 45 minutes, go through that homework. It's 2 free response questions. It's 7 multiple choice questions. Do the best you can, check them, redo any ones you get wrong, and then put it away. You're done studying. Look over these little hints before you go to sleep, do it again in the morning, and you're done. All right? You've done too much up until then. If you're going to do any more study than that, do it early. Do it right now after class or whatever. But there's no need to sit there and cram tonight. All right? With this stuff, you have to be clear-headed tomorrow and be able to think. You got to be able to sit there and decipher what they're asking you. That's why I'm saying relax and do not panic. It's easy to get there and say, oh my God, I know none of this stuff. You do know it. It might just be worded different. So take your time in there, read through it, do the stuff you can do. Do the mechanical stuff, do that stuff early. All right? Then go through and say, all right, how do I do this? What does this remind me of? And if last case scenario, just say, what happens if I take the derivative? What would that do for me? What happens if I take the integral? What would that do for me? Integrals adding stuff up. Derivative is slope of the tangent line, which is rate of change. It's that simple. All right? As far as pencils, bring enough that you're comfortable. Carolyn, you might bring 17. All right? Mark Caruso might bring 1.5. Just bring enough where you have enough where you're going to be comfortable taking. You're not going to be spending time at test saying, do I have enough pencils? All right? So bring as many as you want or as few as you want. Just be ready. All right. Be confident. Anybody asks you how the test is going to be, it's going to be easy. All right? That's what you say. You got to start believing it. All right? It's going to be easy. All right? And whatever happens in the end, enough said. You can't walk in there nervous. This math stuff is not regurgitating information. It's looking at a problem and thinking, how do I solve this problem? You got to be confident. You got to be fresh. So get some sleep. Tomorrow morning, you guys want to meet at like 7:45 in the campus center? Hell yeah.
All right.
You have to be in the library at 8 o'clock. You guys just want to be in the library?
What are we going to do?
Maybe everybody brings a little snack. We just eat. Just bring your own breakfast. Bring a drink.
BYOB.
Right. Just come and hang out. We'll shake hands. We'll just get excited. We'll put our shirts on. All right. So 7:45.
Yes, can we walk to the library?
Hold on. We'll get it time. Don't pack up.
In a pack? Can we walk in a pack to the library?
Have like hoods on.
First of all, what's the dress
Have you
code
seen a
tomorrow?
public desk?
Wait, what kind of pants? What kind of pants?
Everybody white pants, khaki pants?
You might want to go shorts. It's gonna be
Shorts,
hot.
yes. What is?
Yeah.
Can you bring that?
Do you want me
It
to?
might be smart for people that aren't cutting the sleeves off to wear like a t-shirt underneath it, so when it gets hot, just pull off.
Never let them buy the higher underwear.
We're gonna play Flight of the...
Ride of the Valkyries on the way in. I volunteered.
Yes. You have a boom box?
I got this.
Bring it in.
I volunteered to write a letter to ETS apologizing for how well we're doing on this test.
What a lot of people like to do is type in formulas in their memory in the calculator.
You guys had it.
Well,
It's for nerds.
It's very easy, but it's fun. And it's legal. But they know that. They're not going to give you a Newton's method question on a calculator
What's
section.
Newton's method?
Yeah, what the hell is that?
It's approximated to zero.
How do you do that?
X of n minus
Look it up.
f of x.
I've explained it 7 times. Look it up. That's something you
Are
should
we going to be
do.
responsible for like silly area formulas like trapezoids and not trapezoids? Trapezoids is cool, but
Trapezoids
like
and rectangles.
spheres and
No, they give you those.
volumes. And
They
stuff like
give
that.
you like volume of sphere, volume of cones, all that
If they
stuff.
don't, someone's going to be hurt.
Right. So, like,
They don't have it for you.
yeah, if you want to type the product rule and stuff in your memory, go ahead. But you're gonna waste time looking it up. But if it's to make you feel better having this stuff, you're allowed to do that. They don't make you clear memory. It's not illegal. But the ETS also knows that people do that, so they're going to give you those kind of questions on the non-cap.
Who doesn't remember the product?
I'm just as you an example. Don't worry. It's not. But I know a lot of people do that. A lot of people download programs from the internet. Those are for nerds. Not too good.
Greg, did you make something like that? What?
No offense. All right. So have your calculator and be ready. I mean, something like Newton's method. You want to look at the formula? Do it. It's a simple formula.
What is it?
It's like.
It's x of n
One
minus
guess is
f
your
of x
previous
over
guess
n
minus
F of n over.
Yeah, f of
minus the previous guess over the derivative of the previous guess.
It's in the book.
No.
It's in the book. Look it up.
You need to know linearization?
Linearization is pretty much linearization is the idea that the tangent line is real close to the function near the tangent point. That's it. So they ask for a tangent line. They say, well, use the. Let me illustrate this real quick. Use the tangent line to approximate. If you have some function like this, and we draw in the tangent line at that point, we're saying within a real small area, maybe from there to there, the y value of the tangent line is very close to the y value of the function. That's the whole point of linearization.
So if they ask you for like the value of the point, like you never.
Now, if they said use the tangent line to, like let's say this was 4 and this was 4.1. Like in that one question we did tonight, they said use the tangent line to approximate 4.1 after 4.1. And then you find out whatever this value is. And then they said later on, find the exact value of 4.1 that you did, and they were real close to each other. But yeah, linearization is just the tangent line. Yes?
We're not going to need like normal like wimpy calculators for the other part.
No, you're not allowed to use them.
Okay.
They've changed. Yep. All right. Any other questions? All right. Sit down for 45 minutes tonight, and you are done. All right. I will see you guys tomorrow at 7:45. We're going to bring a snack or a beverage.
In the campus?
In the campus center. Good luck tomorrow. Good luck tomorrow.
You going sleeveless?
Yeah, what's the deal with the sleeves?
I already cut mine off, so I am.
No sleeveless.
I like the shirt too much.
Are we returning to Sunday now?
So you already went sleeveless?
Yes. Nate, I'm going to turn this
How many
off.
extra